All right, the next lesson we have is dealing with something we call arithmetic sequences. We dealt with sequences to start in the previous section. Now we're going to be looking at a specific subset of them. Let's get going with the start thinking. How are the following different? I want you to look at the sequence rules and tell me what we have to do to get from one number to the next and keep going. So, looking at these, what's happening to get from 3 to 9 and to get from 9 to 27? Each time, all we're doing is we're multiplying by 3. 3 times 3, 9 times 3, so on. Right, 4 to 7, 7 to 10, 10 to 3. We're not multiplying here. What are we doing? Well, each time we're going up by how much? 3. And now this last one is a little bit harder. 1 to 8, 8 to 27, 27 to 64. Well, we're not adding these, right? We're not getting the same numbers. We're not multiplying either. So we have to think about this a little bit harder. What do we do to the first number, or 1 to get to 1, to 2, right, the second number to get to 8, to 3 to get to 27, and to 4 to get to 64? Well, 8 is the cube of 2. 2 cubed is 8, 3 cubed is 27, 4 cubed is 64. So the rule is we're taking whatever the number is in the sequence and cubing it. All right, let's talk about arithmetic sequences. All an arithmetic sequence is it's a sequence where there's a common difference. So each time we're adding the same thing. An arithmetic sequence is a sequence with a common difference. Right? Common difference meaning that each time you subtract the two numbers next to each other, they stay the same. So same when subtracting. How do we know that this is the rule? How are we going to remember that? Well, this is an arithmetic sequence. The A stands for we're going to have to add or subtract a number to actually get to the next term. Right. Now, how do we look at arithmetic sequences? We said we have two different formulas. We could have a recursive formula or an explicit formula. The recursive definition, and we're going to have an explicit definition. We're going to have a slightly different terminology. We're going to call A here the starting term. If it's recursive, right, we dealt with these before, but now we're looking at this as an arithmetic sequence. It's going to give us some easier definitions. If it's recursive, all that's happening is our newest term will be equal to whatever the previous term is plus our common difference. And we're going to start at whatever our starting term is. Right. Now the explicit definitions were harder to come up with for these rules, right? Previously when we did this, we had to say, okay, what's our n? Well, it's 1, 2, 3, and we'd have to say 4, 7, 10. So we'd have to say, okay, we're adding 3, but then we have to get started with whatever this happens to be, right? We have to figure out, okay, 1, well, we're going to have to start by adding 3 to that, or whatever that is. The explicit definition makes this a little bit simpler. All this is now is we say that whatever term we have is going to be a times, or a plus, n minus 1 times your common difference. And this will work for anything from the first term on, right? We start with whatever we start with, and then we add the common difference all those extra times. Much simpler than trying to figure it out the other way. So if we can remember, or if we can determine that we have a sequence where it's just adding or subtracting, this is all we have to do. All right, let's look at a couple of examples. Let's check whether these are arithmetic sequences. So we'll go 3, 6, 9, 12, 15. Right. What's happening with each of these? Well, each time we go up, we are adding 3. So the recursive definition is pretty simple. Let's write this out in the explicit definition. Our term is going to be whatever we started with, which is 3 plus n minus 1. And what's our common difference? Each time we subtract, we're left with 3. So it's n minus 1 times 3. Let's double check this against the previous way we did this. If this was our first, second, and third term, we're looking at 3, 6, 9. Well, we're adding 3, so we know that this is going to be adding 3. But then we have to get from 1 to 3. So what do? Well, we need a sub n is equal to 3n, right? Each time we're multiplying by 3 and do this, we get to 3. That's the same as if we do this. You just have to simplify this a little bit. All right, let's look at another. Let's say you have 1, 4, 9, 16, 25. So looking at these to see if it's arithmetic, we subtract these, or we see what the difference is. It's 3. This one is 5. And we don't even need to go any further. Those two are not the same. So this can't be an arithmetic sequence. All right, we have a couple more things we can do with arithmetic sequences. Having the knowledge of what it is can allow us to do the work with these a little bit quicker. So we can just be given two terms if we know something's arithmetic and be asked to find some term way down the road. Because as long as this is arithmetic, all we need to know the explicit formula is the first two terms. The explicit form is whatever the first term is plus n minus 1 times the common difference. What's the difference here? It's 5. So this is our explicit form. Now, if we're looking for the 101th term, this becomes 6 plus 101 minus 1 times 5, or 6 plus 100 times 5, which gives us 506. Much simpler than trying to figure this out using recursion or using the previous ways we had for solving the explicit formula. All right, let's say you had something like this. You start with 100, you have two blank terms in between, and we know the next term is 82. We're trying to fill in these two terms. How are we going to do that? Well, how many jumps did we make? 1, 2, 3. So we subtracted 3 times. How much did we subtract? We subtracted a total of 18. So our difference is going to be the total amount we subtracted divided by the number of different times we subtracted it, right? Getting from here, that's 1, to there, that's 2, to there, that's 3. So each time we're subtracting 6, meaning that when we put these in, all we need to do is we just need to subtract 6 each time. 100 minus 6 gives us 94. 94 minus 6 gives us 88. Now, of course, you could do this by figuring out the explicit definition as well. A to the n is equal to 100 plus n minus 1 times negative 6, but it'll just get you the same thing as doing it this way. And finally, we have one more new type. We're talking about means. If we're trying to find the mean between two numbers, we can now do that using sequences as well. Makes our life simpler, and it might ask for something like this. So let's say we're trying to find the mean between 5 and 35. All this is asking for is the difference between these, right? So all we need to do is figure out what the middle term would be. So what we need to do is we can take 35 plus 5 and divide it by 2 to get our number in between. So if you just have one number in between, all you need to do is take the two numbers and split them, right? Because we jumped twice and we're going to be looking at the difference between them. If you have a couple of terms, you're going to have to do this, so it's a little bit more difficult. But with just one term, this is all you need to do. And that's all there is for this lesson, really. So remember, arithmetic mean, we're just adding. We have these two definitions, whichever one suits the situation better, but that's all we need. So let's do some practice problems. I want you to start by telling me whether this is an arithmetic sequence. Let's go with 5, 8, 11, 14, and whether this one is. Next, I want you to look at this sequence and find me the 50th term, and then solve for the two numbers that are missing here. So go ahead and do those. Actually, make sure you're doing these. Pause the video, get started with them, and we'll meet back up in a second here. All right, so for this first one, we have 5, 8, 11, 14. What's happening? To get from 5 to 8, we have to add 3. To get from 8 to 11, we add 3. To get from 11 to 14, we add 3. So yes, this is arithmetic. What about for this one? Well, we add 3 to get to there, but what do we do for this next one? We add 6. That's not going to work, right? We're adding two different numbers. So this is not an arithmetic sequence. For problem 2, we're looking for the 50th term, meaning we're not going to want to do this recursively. We're going to want the explicit formula. What are we doing? Well, each time we are adding 3. So our explicit definition is going to be, we start with 6. So a sub n is equal to 6 plus n minus 1. We add the common difference however many times minus 1. What's the 50th term going to be? Well, it's going to be 6 plus 50 minus 1 times 3. Or 6 plus 49 times 3 is 147. So this is 6 plus 147. Or this is going to be 153, will be the 50th term in the sequence. All right, and for problem 3, we're jumping 3 times total. And how much are we going up? We're going up 30. So going up 30 over 3 jumps, meaning we're going up 10 each time. Means that this is going to be 18 and this is going to be 28. Once again, you could also do this by figuring out the formula. A sub n is equal to our starting term plus n minus 1 times this number. Right, that's it for the lesson. Go ahead and get started on the homework.